So we are continuing our journey to learn physics. Today we'll start the second chapter, force and pressure, motion. Let's see what is in the book. Force, what do you mean by force? Any idea?
Push or pull.
Pressure or pull? Yeah, mainly that is pressure or pull. Rest and motion, kinds of motion. It's very important, no? It's very important, very fundamental things. Rest and motion. If there were no friction, everything will be in rest or everything will be in motion. If there were no friction, then our fan will always move. Always move. Once you move it, the fan will continue moving. Okay? So, very important. Rest and motion. We use the word rest very often. For example, a table is at rest. A book lying on the table is at rest. How do you know that the above mentioned things are at rest? What do you feel actually? What is your perception when you say rest? Well, it is just by everyday experience that we know that they never move on their own. Okay, what is rest? They never move their own. The book, just it is here and it will be continue be here. So this is rest. Okay, means whenever we apply something, push or pull, then only it will move. Otherwise, it will stay here. This is rest. However, we have to answer this question scientifically. We shall say that a body is at rest when its position does not change with time. Scientifically, what the definition of rest? That position does not change with time. The position here doesn't change. Okay, what is rest? Compared to things around, that is, it is surroundings. Here, the table is surrounding. Okay, table is surrounding, your room is surrounding. Compared to that, the book is in its position. It is not changing its position. Okay, now suppose your this one. Suppose this one, like this. Compared to the book or table, it is changing its position. It is not in rest. Okay? So scientifically, always remember how do you express it, how to represent it. Okay? Scientifically, does not change its position with time with respect to. Always with respect to. Remember this phrase. Very important when you study relativity, special theory of relativity, general theory of relativity. If you forget this phrase, with respect to, then you will miss that. We cannot understand it. So it's a very high level physics. Whatever it is, always remember this. Compared to the things around it. Actually, with respect to the other, with respect to your surroundings. Like that. Understood what I am saying? Where I am giving emphasis. Compared to your room. Okay. Compared to moon, is it in rest? No. That's why. Compared to the things around, that is its surroundings. Compared to moon, it's not rest in rest.
Because
it's moving.
the earth is
moving. Yes. So it's very important. Okay. For you just write the definition here. It's okay. But physically, it has a great importance compared to science, compared to surroundings. Why? If you don't write this, then it is not meaningful. Okay. When the position of a body with respect to its surroundings does not change with time, the body is said to be at rest. With respect, here the word the phrase comes. With respect to its surroundings doesn't change with time. Their position with respect to surrounding change with time. These three. There are three conditions to be rest. Okay. We know that a running train is in motion, flowing water. Okay, we know that a running train is in motion. Okay. Flowing water is in motion, etc. How can we say that these situations are example of motion? Why? I'm saying that we're saying that the train is moving. It is in motion. It is not in rest. This is motion. Why? How can I say?
because we see it moving.
Because we see it moving. This is a simple explanation. Scientifically, what we can say?
It changes its
Position with time
with respect
to
its surroundings.
its So fulfilling these three conditions are there. Okay, to be rest or to be in motion. Okay, to be rest, we have studied that there are three conditions to be fulfilled. Now, what is motion? We'll come to know it. Okay, it is because in this example, the position of the object changes with respect to its surroundings with time. A moving object keeps on changing its position continuously with time with respect to its surroundings. So, when the position of a body with respect to its surroundings changes with time, the body is said to be in motion. So, rest and motion, there are three conditions. First, change of position with respect to surrounding with time. There are three conditions to a body to be in rest or motion. Scientifically, you have to remember these three conditions: position, surrounding, time. Okay. Rest and motion are relative terms. Why relative? Here, book is rest. Everybody will say rest. With respect to this, our surrounding. Automatically, our brain calculates the surroundings. But something is in motion. Moon. For that person, the book is moving. For that person, the surrounding will be moon, not earth. Yes, space. You're right. Seemingly, rest and motion are quite opposite to each other. Rest and motion opposite. However, the following example will prove that sometimes it becomes very difficult to say whether a body is at rest or is in a state of motion. Is it really? Sometimes it's very hard to say whether it is moving or it is in rest. Example. Imagine that you are traveling by a bus. If you compare the position with respect to the surroundings outside the bus, such as trees, fields, house, etc., you'll find that your position is changing with respect to them. Hence, you are in a state of motion. Okay? Surroundings means what is? Fields, house, trees. However, if you compare your position with respect to the surroundings inside the bus, that is the passengers, walls, and roof of the bus, you will find that your position is not changing with respect to the surroundings, and hence you are at rest. That an object can be rest relative to one group of objects, while in motion relative to some other group of objects. What they are saying? The same thing. If you are moving in a bus, you are moving or you are in rest. Suppose you are in a moving bus. It's a very tricky, something weird question. Moving with respect to, because the bus is changing its position. Okay, but here if you change the surroundings, you are comparing your surroundings with the passengers in the bus itself, the seat itself, then are you moving? No. It is subjective. That is with respect to. A very important phrase, with respect to. So with respect to the bus, you are not moving. With respect to the field outside the bus, the trees, the house, the fields, you are moving. It's a very, very complicated. It will become complicated in future. Okay, whether you are rest or you are moving. So types of motion. Understand? Rest and motion is subjective. Relative. Okay. What is the word they used? Relative terms. Okay. Types of motion. If you look around at moving objects, you will notice that they are performing different kinds of motion. Yeah. For example, a car moves straight along the road here. Okay. An electric fan rotates and pendulum of a rock moves sideways in either direction. Electric fan rotates. It's not moving away from a position to other position. So electric fan also moving with respect to our surroundings, but the motion is something different. It's moving. The motion is it's standing in its own position, where the car is changing its position from here to there. So two different things. And suppose a pendulum. Have you seen any pendulum? Look at this. Look at this. You can consider this as a pendulum. Okay. Look at this. It is Okay, it's moving here from here, again come here, again come there, and again come here. This motion is something different. Okay, so different type of motions are there. So a pendulum clock, it is like a pendulum. It's move here, then it's come again here, then again go here, then again here. So this motion is something different. Yeah. We shall study the different kind of motion which an object can have. Okay, motion, different type of motions are there. Okay, first we have learned rest and motion, the concept of rest and motion with respect to. Okay, remember this. Now, what type of motions are there? Translatory motions. Imagine you walk 10 paces first along a straight line and then along a curved line. Do all the parts of your body move through the same distance in both the cases? Well, the answer is yes. They move through same distance in the same time. It does not matter if you are moving along a straight line or a curved line. What do you think? The motion in which all the particles of a body move through the same distance in the same time is called translatory motion. Here, it's a translatory motion. Why? The particles of the whole body, all the particles of the body, hold the car, move through the same distance. Same distance. Car is moving 1 kilometer, then the tire will also move 1 kilometer, the bonnet will also move 1 kilometer. Yeah, every part of the car, I'm saying that every part of the car will go 1 kilometer. So all the particles of the body move through the same distance in the same time is called translatory motion. Suppose this car tire move fast 1 kilometer, then the other part will go. Is it possible? You're laughing it, but there are some objects maybe like that. Okay, the condition is for translatory motion, all particles move. That is called translatory motion. Example, a car or a train moving along a road, a ball rolling on the ground, a girl sliding down a slope, whatever. A girl sliding down a slope, pulling out a drawer of a table, firing of a bullet from a gun, a stone hurled from a catapult, etc. are the some of the examples of the motion of translation. The whole body moves. If the whole body moves, then it's called translatory. Rectilinear motion. In translatory motion also, there are two parts. Whole body moves, but how the whole body moves, depending on that, we have found two different kind of motion. Okay, these are important because when calculating some velocity, acceleration, so we need this motions very accurately. We must have this idea, then only we can perform the mathematics calculations. Rectilinear motion. Imagine a ball rolling on a smooth floor in a straight line. In such a situation, the motion is described by the ball is rectilinear motion. When a body moves along a straight line, the motion described by the body is rectilinear motion. Straight line. Okay. Straight line. Translatory motion, the whole body moves, but whole body moves in a straight line. That is called rectilinear. The word rectilinear means straight.
Like a pinhole camera.
Pinhole camera means how camera is moving.
Pinhole camera, the camera where the picture is taken.
Yeah, the light moves in a rectilinear way. Light always moved in rectilinear motion. Okay, always move in straight line. Okay, probably you have got this somewhere. Yeah, last year I've got. That's why it forms shadow, no? Because light prevails in rectilinear motion, straight line. Can you remember? Can you remember something? Okay. Examples of rectilinear motion. A train moving on a straight rail track, but it is not always true. Sometimes it bend is there, curved is there. A car moving on a straight line, straight rail to straight road. A freely falling stone, it's always true. A freely falling stone, rectilinear motion. Okay. Freely falling, yeah, you are asking if you project like this, then it will go and fall like this. It is not rectilinear. Okay. A coin moving over a carom board here. So freely falling objects, they are saying this is stone. Okay. This one. This one. Not like a projectile motion. If you do it like this, it is a projectile motion. You are forcing it against it. It is not freely falling. You have forced it. You have forced it. That's why it's moving here. It is not following a rectilinear. A freely falling means you are not applying any force. Just leave it. then that is freely falling. Okay. Curvilinear motion. Imagine your car is passing over a curved flyover bridge. In such a situation, your car is describing curvilinear motion when a body moves along a curved line. Yeah, you have told that the projectile, if you throw a stone, it will follow a curved line. That is a curvilinear motion. Okay? But you have to apply force there. The motion described by the body is called curvilinear motion. Translatory motions, it has two parts, rectilinear and curvilinear motion. Okay? Here are the example, but always remember when you express something in rectilinear motion, always write this straight line track, straight line road. Examples of curvilinear motion: a ball thrown upward at an angle here. Thrown, not free falling. A car or train moving along a curved road or track. Figure 2.4. This is a curvilinear motion. Next, different type of motions are there. Translatory motion. Next, coming to rotatory motion. Okay. What is rotatory motion? Ceiling fan. Okay. Switch on a table fan. What do you notice? The blades of the fan start moving in a circle about a fixed axis. Such a motion is called the rotatory motion. A motion in which a body moves about a fixed axis without changing its position is called the rotatory motion. Fixed axis. Have you seen the fixed axis? The stand, yeah, the stand, the ceiling fan, here. This is the axis. The axis is not changing. The blades is changing its position. The blades are changing. Okay. Fixed axis without changing its position. This is fixed. And blades are moving with respect to the surroundings. This type of motions are called rotatory motion. Ceiling fan, table fans, wheels with respect to its axis is also rotatory motion. Okay. Wheels have both the motion, translatory and rotatory. Remember this. Okay. With respect to the road, it is translatory. With respect to its axis, it's a rotatory motion. Understand? So is it complicated or something? With respect to. That's so important. Okay. So a spinning wheel, there are the examples, a spinning wheel or a sarkha. This is a spinning top.
But the top changes its position like this. If this is the axis, it goes a bit to the side.
It is because some force is given when you move the top like this, some translatory motion, because of you exert force in that direction. A potter's wheel, a ceiling fan. Okay. Circular or circulatory motion. What is this? A body is said to be in circular motion if it moves in a circular path around a fixed point.
So the ceiling fan is also has a circulatory motion?
Yes. In one type it is okay. But what is the difference? It is fine. It is also a special kind of curvilinear motion in which the distance of a moving object from a fixed point center does not change. Thus, the motion of a body along a circular path is called circular motion. Whether circular motion is a rotatory motion or not. Here, look at this. It has a fixed axis. Here, it has a fixed axis. Here, it is about a fixed point. About a fixed point. That is the difference. The sun, the earth moving around revolving around the sun. Is there any axis?
No.
There is an imaginary axis. So, revolving around this point. Okay. You are moving this stone like this. So, here it doesn't have any axis. It's just moving from this point. Okay. A very subtle difference. Understand? Fixed axis and a fixed point. Now, if you consider only this part, this part, this follows a circulatory point. Suppose one part of this blade, suppose only this is also a circulatory motion. So rotatory motions and circular motions are the same. In a sense, it is same. But here a very subtle difference. A fixed axis here is around a fixed point. Okay. So let's come to oscillatory motion. What is oscillatory motion? Some objects move as a whole, to and fro, okay, or back and forth along the same path without any change in shape, like swing. In such situations, the objects are describing oscillatory motion. Thus, to and fro motion of a body about its mean position is called oscillatory motion. The to and fro or back and forth motion described by an object as a whole along the same path without any change in the shape of the object is called oscillatory motion.